That looks good. Okay. Hi, I'm Don Wunsch. I am the Mary K. Finley, Missouri Professor of Computer Engineering at Missouri University of Science and Technology. And we're in Brisbane, Australia. It's the day before the World Congress on Computational Intelligence, June 9th, 2012. And we're right across from the Brisbane Convention Center. And I'm interviewing Jerry Mendel. And Jerry, please tell us about your title and affiliation.
Okay, Don, I'm a professor of electrical engineering and architectural systems engineering at the University of Southern California in Los Angeles.
Great. And your formal education and training?
Yeah, I got all my degrees at the Polytechnic Institute of Brooklyn. I have a bachelor's in mechanical engineering, a master's in double E, and a PhD in double E.
Great. And what was your first job in engineering or science related job?
Well, I had a lot of summer jobs, and interestingly enough, one of them, I think maybe in my junior year, was at a company, and I found out midway through that Harry Nyquist was working there also. That was pretty
Wow.
exciting. Uh, and my first real job, full-time job, after getting a PhD, was at Douglas Aircraft in their research division, the astrodynamics branch.
Great, great. Um, and your first paper that you published, where was that and what was it about?
Yeah, the paper was published in the IEEE Transactions on Automatic Control. I originally was a control theory person, and it was on different geometrical ways to compute the damping ratio. It was a letter or a short paper in 1963.
Oh, great. And what was your first computational intelligence related publication?
Okay, well, now this is a little bit of a story.
Mhm.
Uh, I was very fortunate when I went to work at Douglas in 1963 to have a very far-sighted boss who told me, Jerry, during the first year, I want you to research, survey what biological principles could be used to design control systems. And so, among other things, I found cybernetics, pattern recognition, but most important to me was learning control systems, which was work that was being done by Professor King Sun Fu at Purdue. And that was an area that I actually did a lot of research in. I actually got the first contract from NASA on that. They wanted a survey as part of what they wanted us to do. I had already completed that. Uh, and so I spent probably 2 or 3 years working on learning control systems and published an edited book with King Sun Fu. We gave short courses at UCLA Extension on adaptive learning and pattern recognition systems. Uh, but I also had conference papers about that. So the first publication in this, now that we call it computational intelligence area, was really on learning control systems.
Hmm. And what persuaded you to study engineering and science?
Well, I guess I started out wanting to be a medical doctor when I went into high school. I even took Latin. And unfortunately, biology didn't agree with me.
Mhm.
And I had been tested, and they said, "Oh, you're very good in math, so try engineering." I also was greatly influenced by a friend of my parents who was a chief engineer at CBS. He was a civil engineer, and we spoke a lot. And I guess he helped convince me that engineering would be a good field for me to go into.
That's great. And in fact, that segues into my next question about a person or people or events that influenced your
Yeah,
decision to
well,
go
I
that
already
way.
mentioned this man. His name was Mike Salgo, and my first boss at Douglas, Mal Abzug. But probably the most influential person on me was John Truxell. When I was a senior at Brooklyn Poly, I had a service course in electrical engineering. And for anyone who knew John Truxell, he was an unbelievably dynamic teacher. And he just persuaded me
Hmm.
that I could change from mechanical engineering to electrical engineering without missing a beat. Get
Oh,
my
great.
master's in double E in 1 year, and that was it.
Yeah, that's amazing the influence
Yeah,
that a professor can have at that stage
yeah,
in one's
very
career.
important.
But I know that you also have found the relationships with some of your students to be transformative.
Yes, that's true. I would say that all my students have
Uh-huh.
transformed me. But stepping back over my, let's see, I started at USC in 1974, so I hate to say it, it's almost 40, no, 40 years. Oh
Yeah,
my
2
God,
years from now,
where
it'll be
did it
40.
go?
Yeah, yeah.
Uh, but at various points over that period of time, a specific student moved me into a new field.
Hmm.
Uh, and I don't know whether it's been your experience, but
Yeah.
professors don't have time to sit and think, what's the next area that I'll move into? You get a smart student and they do it, and then all of a sudden you find yourself swept into this area.
Right. Their desire to get into an area really can be contagious.
Oh yeah,
So,
oh
yes,
yeah,
yes,
it's
absolutely.
very exciting.
Yeah,
Yeah.
that's great.
So that happened to me in geophysical signal processing, in statistical signal processing, and then in the computational intelligence. In the mid 80s, I had I was giving a course on nonlinear signal processing. I wasn't doing anything on fuzzy or anything like that. And there was a project where the students had to use this software that we had developed to do this processing. We had real data that I got from another student who was working at Unical at the time. And so one of my students had taken this course, and afterwards he came to me and he said, Dr. Mendel, I could see certain stuff in the data, but I didn't know how to incorporate it using the statistical based stuff. But I've read about fuzzy logic and I think I could have done it. Well, in 1986, I was president of the IEEE Control System Society, and I did not have a very high opinion or impression about fuzzy logic. I thought, this is some area, and there's this cult leader named Lutfi Zadi. But at that time, no self-respecting control theory person would dare to go into fuzzy logic. But this student was very persuasive. He gave myself and a group of my students lectures over the whole summer. And when he got to Gauguin's category theory description, that's when some of these students said, oh, category theory, okay, this must really be legitimate mathematics.
Oh, that's fascinating because
Yeah,
I did one of these interviews with Tom Caudell, and he, together with Mike Healy, are looking at category
yeah.
theory implications in neural nets. So, who was this student that got excited about
Well, his name was Robert Popoli, or
this? Hmm.
Popoli.
Hmm.
Uh, he did some work on fuzzy. Uh, he was working on a big target tracking problem. It
Hmm.
was a submarine, and there was all sorts of noise, biological noise and machine noise, and you wanted to track a target. And he was using extended Kalman filtering.
Hmm.
And what he did is he came up with this idea to add a rule. And the rule was if I'm tracking a target at one time instant, it will not be too far away at the next time instant. Now, submarine's big. How far can it go from one time instant to the next? Well, so I said, well, how are you going to incorporate that? He says, well, I'm going to write a rule and I'm going to use the mathematics of fuzzy sets, and then I'll treat it like a prior and a Bayesian, and I'll optimize. Unbelievable. In extremely low signal to noise ratio, we were able to track that target.
Wow,
Yeah.
that's great.
But then my first 100% fuzzy student was Li Jing Wang.
Hmm.
I had met him in 1986 when I visited his university in China, not to do anything on fuzzy. Uh, and then a couple of years later, he contacted me. He sent me a pile of papers. I found my name on it, so I told him, no, I didn't do anything with you. But one of the things that he did, which I still find amazing, is when I had gone to China, I had given a 5-day short course on seismic deconvolution, and we had invested a decade. I have 2 books on this thing. And Li Jing developed 3 Hopfield neural networks that solved everything that we were doing. And when we tested it, the statistical based versus the neural network blew it away.
Wow.
Well, because the statistical depended on the data model. If the data agreed with the model, then you do very well. But real data never agrees. And the neural didn't make that assumption. And so it did very, very well. So we actually published that in, I guess it would be the Transactions on Neural Networks back then.
So students who are watching this video, if you want to get recruited by some of the top professors in the field, the way to do it is to get interested in what they're doing and then show them results that blow their mind. And
Boy, that's a good point.
yeah,
Absolutely.
that's a great way to get on board if
Yeah,
you can do that.
yeah.
Yeah.
Well, Li Jing was an amazing student. He came to USC about a month after Tiananmen.
Wow.
Yeah, he showed up. He even called me from China and said, "Don't worry, I'll be there."
Wow.
And he came, and when he took his qualifying exam, we had already published articles in 3 different areas. And so, of course, he passed. But afterwards, when he stepped outside, the professors told me, yeah, the guy's really good, but he needs to focus on something. So I gave him the choice. Which one of these areas do you want to choose? Thank goodness he chose fuzzy.
Right.
Because if he hadn't made that choice, I would not have continued working in the fuzzy field.
Wow.
Yeah.
Yeah, that's amazing.
So again, it's a great example of how a student can make a huge difference.
Yeah, it's taken for granted, we're in the business of making a big difference in students' lives, but it
Yeah.
can frequently
no.
go the other direction too.
No,
Yeah,
it's a two-way street.
absolutely. Um, so, so what triggered your jump into a computational intelligence technology? I guess this is part of what.
Well, as I mentioned, the student Robert Popoli got me interested, but then Li Jing is the person who really propelled me.
Mhm.
And I was able to get NSF support uh, actually from a signal processing group because we told them we're going to do fuzzy signal processing, which indeed we did.
Mhm.
So I think that he was such a good student. I mean, my 2 most highly cited papers are papers co-authored by him. They have very large numbers of citations. Uh, he went off afterwards to do a postdoc with Lutfi, and he wrote two books. One more research monograph, but the other a textbook that's still being widely used on a first course on fuzzy logic. Very well written book. So he's the one who got me started, and then because I had this funding, I could continue with the next student and the next student. Uh, and I've thought about why I moved from what now we call type 1 into type 2. And I think it goes back to what I had done in the control, then the statistical signal processing. When I was working in control, I never really did a lot in design of control systems. It was more on estimation, system identification, dealing with uncertainty. And then I moved into the seismic. There was more uncertainty. And then the higher order statistics, more uncertainty. And so I was always interested in, okay, so now how do I handle uncertainty in the fuzzy framework?
Mhm.
And that's how we made the segue from type 1 to type 2.
Okay. Um, so, uh, what was your first computational intelligence related activity?
Um, Yeah, that's a good question. Well, I remember that we went to the first Fuzz IEEE conference, and Lutfi Zadi had found out about the work we were doing, and it was very interesting. At that meeting, there were three papers that were presented by three different groups in different countries. Li Jing and myself was one of them, on how you could how you could optimize the membership function parameters using like a backpropagation kind of an algorithm, because it turns out that you can graphically decompose a fuzzy system so it has a layered structure. Li
Hmm.
Jing actually is the one who came up with that idea.
Hmm.
Uh, and so Lutfi asked Li Jing to send him up some slides that he wanted to use. And during his plenary tour, Lutfi's plenary tour, he used 8 of those. So we were very excited about that. I kept wanting more, more, more. Okay, 8 is a
That's great.
lot
That's great.
to
Yeah.
use, but I think that that is an indication of Lutfi's generosity.
Yeah.
Very helpful to have Lutfi basically introduce you. That was our first fuzzy papers,
Right.
and here he's showing these things in his plenary tour.
It's
That
like a
helps.
it's like a novelist having Oprah
Yeah,
to
good
endorse it. Yeah,
analogy.
yeah.
Yeah, yeah,
And
yeah.
Lotfie's still doing that. He's so
Yes,
generous that way.
yes,
Yes.
very generous. And I think that I've tried to help young people also. I
Sure.
think we all learn that from Lutfi.
Yeah. Yeah. There's nothing like a good example. So what was the major challenge you faced in your pioneering research?
Well, I mentioned that we made the transition from what people now call type 1 to type 2. So in type 2, the membership function is itself fuzzy.
Hmm.
Sometimes I jokingly say that a type 2 fuzzy set is a type 1 on steroids. So instead of having a point value membership function, you have a fuzzy set. There's
Hmm.
uncertainty about it. So the membership function for a type 2 is three-dimensional.
Hmm.
Okay. And the biggest challenge was when you want to uh, use type 2 in a fuzzy system, a fuzzy logic system, you ultimately have to get down to a number. So,
Hmm.
how do you go from a three-dimensional membership function to a number?
Hmm.
That was the most challenging thing we faced then and ever.
Hmm.
Uh, and my student, Nilesh Karnik, who did a lot of the pioneering work on type 2, spent months. He would come into me with one idea after the other, and being a professor, I would shoot them down left and
Hmm.
right. And finally, he came in, and I knew as soon as he started telling me that this had to be the right thing.
Hmm.
Basically, the idea was to recognize that this three-dimensional function could be carved up into very simple wavy slices, each one of which is very close to a type 1.
Hmm.
And then you could determine the center of gravity of each of these wavy things and put them all together, and you would get a type 1 fuzzy set. Now, in practice, you can't do what I just said because you have an uncountable number of these wavy slices. So his real brilliance was to come up with an algorithm that is extremely simple, that lets you do that.
Hmm.
And people have called that the KM, the Karnik-Mendel algorithm. It is unbelievably simple. And he did that like in 1998.
Hmm.
So it's a long time ago. And there have been many, many, many articles published about that algorithm, speeding it up, enhancing it, getting rid of it, seeing how fast it converges. So it's almost taken on like a life of its own. But
Hmm.
regardless, that algorithm is not only the bread and butter algorithm that everyone uses in a type 2 fuzzy system, but now we're finding in the work we're doing in computing with words that we need that algorithm for all the computations that we use.
Wow.
Yeah. Uh, So he once sent me an email a long time after he finished, and I was telling him about all the articles that people are publishing about that. And he said, I had a feeling that that simple algorithm was important, but I didn't realize, how important it would be.
Hmm.
So I like the fact that it was so simple,
Yeah. So
really simple to understand, to derive.
a lot of the best work is,
Yeah, yeah,
if you look at Einstein's work, a lot of his writing about it is very lucid and simple. Yeah.
yeah. But interestingly enough, sometimes the algorithms that are simplest to derive are the most difficult to analyze.
Hmm.
There seems to be some inverse relationship between ease of deriving something versus ease of understanding it mathematically.
Hmm.
I think they're inversely proportional.
Hmm. It wouldn't surprise me. Um, what contribution gives you the greatest satisfaction?
Well, I think it would have to be the work on the type 2 fuzzy systems. Lutfi introduced those type 2 fuzzy sets, 1974. A small number of people made important contributions, and we were lucky. Nobody had used them in a fuzzy system. And
Hmm.
Neelish and I put everything together, and it just opened up
Hmm.
the whole area. And that's very satisfying to be associated with something like that.
Yeah, and then of course there's the timing and the
Timing is very, very important. But actually, if we have a minute, there's sort of an anecdote that
sure.
I would like to say. At the time, I was working with an undergraduate student who wanted to do work on fuzzy. And to make a long story short, we decided we're going to write a paper that any high school student could understand, but we needed an application. And the application we finally chose was flirtation.
Oh.
We figured every high school kid, boy and girl, would be interested. And why I chose that is because everybody's familiar with I'm getting mixed signals. And I could see how if you fired multiple rules, one said you're not getting very much, another said a lot. You had to somehow aggregate that, and that's what we do in a rule-based system. So a couple of my colleagues at USC got interested in that. They were psychologists, and they thought we were doing path-breaking work in experimental psychology, which sort of gave me a laugh. We were conducting surveys, collecting data from people, and that's when I first realized that, whoa, I couldn't do certain things with these type 1 fuzzy sets. I was getting histograms for consequence. What do I do with that? Uh, we were finding out when we tried to collect membership function data from groups of people, they didn't all agree. So there was uncertainty about them. What do you do with that?
Hmm.
Lutfi's idea of type 2 fuzzy sets came into my mind, and then I just gave it to Neelish. And so, but it was really this undergraduate project that
Oh.
opened up these new problems.
So did you guys publish some papers with the word flirtation in the title, or?
I actually have a book chapter with these two women psychologists and Matt Martin. It was in a book. It's all about, the fuzzy logic flirtation advisor.
Wow.
Uh,
Wow.
but then in a more recent book with Dongruei Wu called Perceptual Computing, that was published in 2010 by IEEE Press, one whole chapter is devoted to that application because we didn't know how to do a lot of things. It took
Hmm.
a decade for us to figure out how to do many, many things, but they all involved these type 2 fuzzy sets. One of them was extremely challenging, and that is how do you go from data that you collect from a group of people into a fuzzy set model?
Hmm.
Okay, and it took a long time for us to figure out how to do that, but we came up with a method. And so we know how to collect very simple data from people and map it into these footprints of uncertainty that we call, so that we can transfer the uncertainty, words mean different things to different people, into a fuzzy set model. Uh,
Wow.
So data and measurement play a very, very important role in what we're doing now in this computing with words, but we use these type 2 fuzzy sets to do the computations.
Good, good. Um, what do you think the impact that the Computational Intelligence Society and its precursors has made on you?
Well, it's changed my whole direction, my whole life. uh, I was very fortunate to be able to get involved at various levels in the society. This actually is the second society where I've been on the administrative committee. The first was the control system, and now the Computational Intelligence Society. But to me, the most fun is getting together with these people, all of whom, are very brilliant people like yourself, and just
Yeah.
interacting with them. And so my advice to young people is get involved in an IEEE society, start at the bottom, pay your dues, and good things will happen.
Absolutely. I couldn't agree more. And you
Yeah.
wind up looking forward to these meetings,
Oh,
all
yeah.
year.
Oh,
I'm already looking forward to the one next year, and
in
so on. Yeah.
Singapore?
Yeah.
Or,
Well, there's several next year, of course,
yeah.
because in the even numbered years they're all together, and then the odd numbered years they're separate. But yeah, I'll probably get to the one in Singapore, and then the IJCNN will be in Dallas.
Oh,
And,
yeah, the fuzzy one is in India next year.
oh, great. Yeah.
Yeah.
Well, very good. Um, what impact have you made on the CIS and its precursor societies? Of course, you've done the AdCom. That's a huge impact right there.
Right. Well, I've done a lot of work in the education aspect. I like to get involved in tutorials. I have a number of online tutorials. We have an education committee,
Hmm.
and I've done a number of things. In fact, if you go to the website of the society, on the front page, you'll see something called the Fuzzy Logic Video.
Hmm.
Okay. I ran a competition last year. We offered cash prizes. There are two videos.
Hmm.
One is an animated video that's really good for middle school, high school kids, and another is aimed probably more at, well, it could be high school. It's a more serious one, and
Hmm.
college, and that was a lot of fun. All the work that I did on that was with very young graduates. Some are still some are still going for their PhD.
Oh, great.
That was a lot of fun to see how this whole process unfolded. I personally like to get involved in activities that have not been done before.
Hmm.
To me, that's the most fun. It's sort of like research.
Yeah.
You
Yeah.
never know where it's going to go.
Yeah. It's great to have some initiative that involves,
Yeah.
other good people trying to make something good happen
Well,
in the
again,
society.
my advice to young people is that a society like our society gives you the opportunity to do things that have never been done before.
Right. And you're a lot more likely to do good things on several levels, both in service and in research, if you're mingling with people who have paid their dues and done those things themselves. So it really is a great direction for
There's nothing like
young
going to
scientists.
this meeting and having a talk over a cup of coffee or a cup of tea
Yeah.
and discovering this or that, and then somebody invites you to their university. I, the synergism is unbelievable.
Right. It's kind of the punctuation of one's career narrative, really. These are
Yeah,
and their explanation points usually
right.
at these
Yeah, yeah.
conferences. What impact has our society made in engineering and science?
Well, I know that the technologies are being used. Uh, I think it's probably too early.
Hmm.
Uh, I don't think the dust has settled.
Hmm.
Uh, each of our three major areas keeps developing new algorithms, new networks, new this, new that. But history has a way of separating the wheat from the chaff, as they
Yeah.
say.
Uh-huh.
It's fun being in there and developing what you think is a great idea, only history will reveal whether others thought it was a great idea.
Hmm.
And I think not enough time has gone by. There are certain things. I mean, for example, Widrow's LMS. Now that
It's
certainly has
very clear.
withstood, and it's so simple.
Right.
Okay, it's a great example of something being used because it is simple.
Hmm.
Mamdani control, it is simple. It
Hmm.
can do something that others can't do. Uh, those are two examples of what I mean.
Yeah, I completely agree with that. Um, how do you, and so this is sort of related, how do you envision the evolution of computational intelligence technologies? Do you see any expected confluence of computational intelligence technologies and any expected new entry?
Well, I know that my students and I make a lot of use of the evolutionary computing stuff because we're always optimized, tuning a fuzzy system. And I suspect the same is going on in neural networks. Whenever you
Right.
want to optimize, so it's really great to have EC that's
Hmm.
they're inventing all these biologically inspired algorithms.
Hmm.
Uh, I would like to believe that what we're doing will also make an impact. Now, whether it's on type 2 fuzzy systems or whether it's on computing with words,
Hmm.
uh, computing with words is an area that, again, Lutfi invented. But a lot of people don't realize is although he gave it this name maybe in the middle 90s, uh, his very early publications were really all about computing with words.
Hmm.
Uh, at that time, no one really understood what to do with fuzzy sets, but I personally believe that he didn't invent them to be used by controls people who were the most critical. It's kind of ironical that they're the ones who picked it up first. And it's still the most widely used application, fuzzy control. Uh, but if you research his early articles, you'll find that a very large number of them are in non-engineering publications.
Hmm.
And those now are again surfacing because of this area that he's called computing with words. And I think that, well, again, this may be 20 to 40 years,
Hmm.
just as, fuzzy systems has taken 40 years to get where it is. It's going to take that long for this computing with words. And my prediction is that fuzzy will make a bigger impact on that than on the other stuff.
It's certainly an important area. Any impact is going to be
Yeah.
important in that key area. Um, So this is related to the next question. Do you predict any scientific or technological breakthrough involving computational intelligence?
It's hard to tell. I, uh, I think that we just have to encourage young people to come into this field, and if they're bright, good things will happen.
Hmm.
I just see it. I mean, I had a student, Don Gruey Wu, who just an amazing student,
Hmm.
uh, and more of them show up.
Yeah.
Uh, and I think that I've been fortunate to have gone through three fields where I've seen it's almost like these, atomic explosions occurring technology, the control systems field in the late 50s, middle 60s. My God, Lyapunov stability theory, dynamic programming, Pontryagin maximum principle, stochastic approximation, uh,
That's incredible.
Popov stability. I mean, it goes on and on. Yeah, but then it took 20 years to sort through all that stuff. Then I moved into statistical signal processing, and there were other things, higher order statistics, time frequency, others that I've forgotten. Okay, and a big flurry of activity, and now it's taken another 20 years to sort through all that. I think a similar thing is happening in computational intelligence. We're seeing all these methodologies and algorithms and stuff like that. it's going to take time to sort it all out.
Hmm.
But some will survive, most will not.
Hmm. Um, do you have any final comments?
Well, I would like to encourage young people to come into this field. I think it's a very exciting field. Um, it, you know, it's not the penultimate solution to every problem. So I think you need to be well grounded in other methodologies, but it gives you an opportunity to try probably what some people would call some pretty way out stuff.
And it's great for people who like to collaborate too, because
Oh,
if you're
there
in
you go.
computational intelligence, you can work in so many different areas, and it really gives you an appreciation of what all the other people are doing when you can help people in so many different disciplines with computational intelligence
Yeah, that's a
techniques.
very good point. Yeah. I know in this computing with words area, you get involved with linguists and psychologists, speech processing kinds of people. And if you really want to do something that's going to make an impact, you really need to, yeah, you really need to collaborate with other people.
Well, I'm definitely going to look up some of your work that you've mentioned that you've targeted at really young people like middle high school students because they're our future. And so
Well, if
that's
you go to my website, you'll find this report on the
great.
website.
Great.
My granddaughter read it when she was 14,
Oh,
and she
good.
said, "Oh, I understand fuzzy sets. There's no equations in it." The young man, Matt Martin, created a report that's very entertaining to read.
Good.
Yeah.
Well, I will look at it, and I recommend our audience to do so too. So, well, I thank you very much, Jerry.
Okay, thank you for giving me the opportunity. It's actually been a lot of fun.
Yeah, I've enjoyed it too.